In this video, I'm going to focus on how the unit circle can create graphs of sine, cosine, and tangent on the xy coordinate plane. Using review concepts from geometry, the special right triangles, and review concepts from Algebra 2, the xy coordinate plane, we will see how the unit circle actually can produce graphs. So the assumption in this video is that you have seen the video or understand how the first quadrant is constructed using special right triangles from geometry, and that you have seen the video or understand how those values extrapolate all the way around the unit circle to produce all of the values. All right, let's get started with the graph of sine. So to understand what's going on, the unit circle's purpose is actually a calculating device for angles and measurements for sine and cosine. And so in this particular case, since we're doing sine, we're going to eliminate the cosine values just temporarily so we can focus on sine. And so what ends up happening is I have a unit circle that's limited to inputs of angles and outputs of measurements. So I input 0, I output 0. That is my first coordinate pair. I input pi over 6, I output 1/2, making a coordinate pair. I input pi over 4, I output root 2 over 2, making a coordinate pair. I input pi over 3, I output root 3 over 2, making a coordinate pair. And pi over 2 and output sine of 1, making a coordinate pair. Now, looking at those coordinate pairs, you might say, how in the world are we going to graph these irrational numbers? The graph paper itself is set up with 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6 pi, and so on in the actual graph paper as a line to graph. And the output values, which many of them are also irrational, I simply type them in the calculator to get a value. 1/2 is 0.5, root 2 over 2 is 0.707, and root 3 over 2 is 0.866. So when we graph these points, we're just simply going to graph them on the graph paper. So also notice that when we do this, that the values keep repeating. So let's just take a look at the first quadrant. So 0, 0, and so on. 0, 0 is right here. This is pi over 6, this is pi over 4, this is pi over 3, this is pi over 2, this is 2 pi over 3, and so on. So at pi over 6, I've graphed 0.5, just like you see here. At pi over 4, I've graphed root 2 over 2, but I graphed it as 0.707. And then at pi over 3, I have graphed it as root 3 over 2, but here it's graphed as 0.866. And then at pi over 2, I graphed 1. So this right here are these points graphed on the unit circle. And then we start to repeat, but we need to remember that mnemonic device that we had. All students take calculus, because this really will help us with understanding how the graph works. All trigonometric values are positive in quadrant 1. Only sine is positive in quadrant 2, only tangent and only cosine in quadrant 3 and 4, which means these quadrants will have negative sine values, as you can see here. So at this point, we still have positive values. They're going to start high and go low. As you can see here, we start at root 3 over 2, root 2 over 2, 1/2, and then we're back at 0. That correlates right there. Input pi, output 0. And then we start having negative values, negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1. And this is quadrant 3. And in quadrant 4, we have the same values, but they start to go back to 0, and we finish our curve here, and this is what's known as a sinusoidal curve. And it appears that the domain of this graph is 0 to 2 pi. And the actual word for that in trigonometry is the period or cycle. And the reason is the graph will keep going this way and keep going this way, representing our coterminal angles and our negative rotations. As you saw from video 3, these values just keep going, and they also go in the other direction and are simply labeled different things. So this is 11 pi over 6, but I could also call this negative pi over 6, and that would be at negative 1/2, and that would be the dot that would be right there. So that original thing we saw is called the period, and that period is 2 pi. The domain is actually negative infinity to infinity in interval notation. Notice parentheses as a review, because I cannot include the value of infinity, so I have to use parentheses. And verbally, that is all real numbers. The range is negative 1 to 1, because the range would be negative 1 to 1. And that value right there, keep in mind these do curve back down, so that is the minimum and maximum from Algebra 2. They are inclusive, so notice I used a bracket. And so in interval notation, that would be inclusive bracket -1 to 1 inclusive bracket. Now that brings up another vocabulary word that's based on review concepts from Algebra 2, which is if the range is -1 to 1, in trigonometry we have something called the amplitude, and that is how far a graph will rise or fall from its midline, always being a positive number because amplitude is how far, distance is positive. Now this midline can move up and down using translations and transformations, which we'll talk about in a later video, but the definition of the amplitude is how far it goes from the midline to its min or its max, a connection to Algebra 2. So let's take a look at cosine. Oh, before I do that, my apologies, let's talk about the fact that this is a lot of information, and if the video is going to focus on parent functions, if you remember from Algebra 2, we only have usually 5 points for parent functions. So we like to focus on values that are the most readily understood, so typically we focus on these dots that I have colored in black, because 0, 0, 1, 0, -1, and 0 are really easy to remember, and that makes 5 points. 0, 0, pi/2, 1, pi 0, 0, -1, and 0, 0. So to graph the function, the parent function would only be this much as long as you know the curve, because you might accidentally draw some thing like that, which is not a curved shape. So the key points are 0, 0, pi/2, 1, pi 0, 3 pi/2, -1, and 2 pi 0, drawing a sinusoidal curve, understanding that it does keep going infinitely in both directions. All right, let's take a look at cosine. So cosine, similar process, but we're going to temporarily eliminate the sine value to use a calculation for cosine. And what ends up happening is we have the same idea. We're going to input 0, but now we're outputting 1, making this coordinate pair. Input pi/6, output √3/2, input pi/4, output √2/2, input pi/3, output 1/2, input pi/2, and now we're outputting 0. Now you might notice that a lot of these values are repeating. In fact, this value is the same for both sine and cosine. These values here are similar. These values here are just reversed. So we still have the same decimal equivalence, but what ends up happening is that this, instead of starting at 0, it starts at 1 and then goes downward. So you can see that we start at 1, then we have √3/2, then we have √2/2, then we have 1/2, then we have 0. So the graph starts high and goes down. And going back to that mnemonic device, all students take calculus. Notice what happens with cosine. Everything is positive here, but then only sine is, making cosine negative. Only tangent is, keeping cosine negative. And then here, cosine returns to being positive. So if you take a look at the next quadrant, we're going to be negative, more negative, more negative, to the minimum of -1. Then we're going to start going back to the x-axis until we get to 0, and then we're going to start going up again. So quadrant 2, you can see, is right here. Here is quadrant 3, we're going back up to 0, and then quadrant 4 going back up to 1. And again, it appears that the domain of this graph is 0 to 2 pi. That is, again, called the cycle or period in trigonometry. The actual domain, because of coterminals and negative rotations, right, going infinitely, is again -infinity to infinity. The range is inclusive bracket -1 to 1. I still have the same minimum and maximum Algebra 2 concept, and that minimum maximum yields this vocabulary word of amplitude, which is how far something rises or falls from the midline. Rises 1, falls 1. It is the range, but it has a different connotation in trigonometry. So the parent function points for this, again, there would only be 5 values. We're again going to focus on the axes values. So the parent function points for this are 0, 1, pi/2, 0, pi -1, 3 pi/2, 0, and 2 pi 1. All right, let's move on to our last one, which is tangent. So tangent is created by dividing sine over cosine. Keep in mind this point is just a regular old point on the coordinate plane, and that point is 1, 0. Okay? So if I try to figure out what tangent is sine over cosine. So sine over cosine, or y over x, is 0 over 1, which is 0. But to create the pair, to create the coordinate pair for tangent, I'm not going to look at this. I'm going to look at inputting the angle of 0 and outputting the value for tangent of 0. So the first point for tangent is 0, 0. For the next one, I would input pi over 6, and I would output root 3 over 3, and that comes from dividing the sine and cosine values. I would input pi over 4, I'd input 1. In this case, the sine and cosine values are both the same, so it makes sense that that is 1. I'd input pi over 3, I would output root 3, which is, this is the sine, this is the cosine value. I would input pi over 2. Remember, this point is 0, 1, so it would become 1, 0, but again, I don't want to look at that. I want to look at inputting pi over 2 and outputting undefined. So a couple of things here. If you don't know how I got these values, they are included in my first video on the unit circle. They are simply calculations from, they're really calculations from geometry and rational equations from Algebra 2. These values I've typed into the calculator here because we have some new irrational values. And undefined, remember from the rationals chapter of Algebra 2, is an asymptote. So we focus here again on 0, asymptote, 0. We have another asymptote here and then back to 0. And these values we're simply going to graph as pi over 6 and 0.577, pi over 4 and 1, and pi over 3, and then in this case 1.73, and then an asymptote. So you can see those points right here. I start at 0. I then have a value at pi over 6 of 0.577, and then at pi over 4 I'm at 1, and then at pi over 3 I'm at root 3, which is 1.77, and then an asymptote at pi over 2. And then again, that mnemonic device, it's so important. All students take calculus, so all values are positive here, including tangent, but only sine. So notice tangent is negative. And then tangent is positive. Notice the values are positive. And then cosine is positive, so tangents are negative. Please keep in mind also that tangent is understood as the slope of the hypotenuse of those special right triangles. So these special right triangles have a positive hypotenuse or positive slope value. These have a negative hypotenuse or negative slope value. And notice that these values, they correlate because they're the same line, right? They're the same line. So this is negative. These are both negative. These are both negative. These are both positive, 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 0, undefined. They are the same line and therefore have the same tangent or slope value. So going back to this, we're at the asymptote. Then we're going to have negative values below the x-axis. Then we're going to go back to 0 and have positive values. Then we're going to have an asymptote at 3 pi over 2. And then we're going to go negative again. And you can see that right here. Negative values. At pi, we're at 0. Then we go back up. Then we have an asymptote at 3 pi over 2. And then we have values here that are negative and then go back up to 0 at 2 pi. And the parent function values for that, I like to think of it as 0, 0, asymptote, 0, asymptote, 0. And then we do need at least one value to show the curve. And so we use the pi over 4 values, all of them 1, negative 1, 1, negative 1. So when I graph this, I graph it like this. 0, asymptote, 0, asymptote, 0, 1, negative 1, 1, negative 1, and then I show the curve that does sort of resemble a x to the third power or cube graph. So now let's talk about the interesting domains and ranges for tangent. The range, fairly simple. Negative infinity to infinity. It looks kind of weird. It does have these asymptotes, but that does not affect the range. But when you talk about the domain, first thing I want you to notice is that the graph does keep going. So it does go this way, and it does go this way due to the coterminal and negative rotational angles from the unit circle. But notice that if you look at the unit circle, tangent completes all of its values, 0, positive, 0, undefined, negative, 0. It does it in pi, not in 2 pi. So you can clearly see that between these two asymptotes here, from pi over 2 to 3 pi over 2, you have 1 pi, and that represents, again, that actually represents from here, right? It starts here, represents from here to here. That's half the unit circle. So its period is pi, not 2 pi, okay? And that repeats. Again, it would also repeat here, and then it would keep going. And so it does have a domain that keeps going, but it's interrupted by these asymptotes. And you might have already looked like, whoa, what is that super long domain? It's actually a review of multiple concepts going all the way back to Algebra 1. So let's talk about it step by step. The first thing is x, such that x is a real number. So we know that all the domain x values are real numbers, okay? But then we have these exceptions at pi over 2 and 3 pi over 2. And if this was Algebra 2 class and we were talking about asymptotes when we saw them in either in logarithms and exponentials or in the rational functions chapter, we would simply say the domain is all real numbers except x cannot equal 1 or 3. And so you can start to see that here. So where in the world did this come from? This actually is a review from the chapter on sequences and series. So I have a little demonstration of how this happens. So as you see, we have on this graph, we have asymptotes at 1, 3, there'd be another one at 5, and there'd also be ones at -1, -3, and -5. So if I take a look at that, I have 1, 3, 5, 7, and so on. So if I look at that, if I take that sequence of 1, 3, 5, and 7, and I apply the equation for arithmetic sequences, plugging in 1 and the common difference being 2, and I distribute and simplify, I end up getting the equation -1 plus 2n. And that is the equation you see that I have put in here. It's actually reversed in this just because that's the way that trigonometry writes it. So for sequences of series, this would again be -1 plus 2n, but here we have 2n minus 1, and then pi over 2. So as you can see, this is saying odd pi over 2 values. This is mathematically saying odd from sequences and series, and then we have pi over 2. And the last problem is, well, what is n? N means number. So then we say, well, n is actually an integer, meaning n is actually 1 or 2 or 3 or 5 or 7 or 0. If I put any of those in there, I would have an asymptote. If I put 0 in there, I'd have negative pi over 2. If I put 3 in there, I would have 6 minus 1 or 5 pi over 2, the one that's over here. You can actually simplify this a little bit by simply putting z there, and this is traditionally what you see is someone will just combine those two and say x, such that x is a real number, but x is not equal to odd integer values of pi over 2. And I know that looks complicated, but if you would rather just write it out and say all real numbers except odd pi over 2 values, that would be a great start, and then you can try to piece this together one piece at a time. All right, I hope you have enjoyed this video, and I hope it has helped you with understanding how to graph graphs and use the unit circle to make parent functions for sine, cosine, and tangent.